So your voice AI works in the demo, but in production it feels slow, clunky, unnatural. I'm going to tell you right now, this isn't a problem with your models, it's a problem with your architecture. Today, we are going to declassify the 3 critical mistakes that are absolutely killing your user experience.
Look at this. On the left, a 2.5-second delay. Sure, it's functional, but it feels like you're using a slow, clunky tool. Now, on the right, you get a response in under 300 milliseconds. That feels like a human conversation. The difference here isn't intelligence, it's all about perceived speed. And that's the gap between a system that just works and one that users will actually trust and want to use.
And that number, 500 milliseconds, it isn't just some performance benchmark. You should think of it as a psychological tripwire. Research shows that as soon as the delay in a conversation goes past half a second, our brains start to register the whole interaction as disjointed and unnatural. Trust starts to break down. Your AI immediately stops being a helpful partner and just becomes a frustrating obstacle.
So let's just be brutally honest here. Your architecture is killing the vibe. We're not talking about those perfectly curated demos you run on your own machine. We're talking about real-world production systems that are failing the most fundamental test of all, the human interaction test. And it's not because the AI is dumb. It's because of foundational, deep-seated architectural flaws.
So, first up, let's break down the core problem. I call it the latency illusion, because the source of all this lag is often hiding in plain sight, right inside the structure of your own stack.
Here it is, the first major mistake, the sequential model stack trap. You take the user's speech, you send it to a speech-to-text model. Boom, 300 milliseconds gone. Then you wait for that entire text and feed it to an LLM. There goes another 1,200 milliseconds. Finally, the LLM's full response goes to a text-to-speech model, adding another 600 milliseconds. By the time the user hears a single word, over 2 full seconds have passed. It's just a cascade of latency.
And this approach fails because each step has to completely finish before the next one can even start. What you get is cumulative buffering, multiple network round trips, and this constant overhead of rebuilding context. You can't just optimize this away, it's a fundamental architectural flaw. It proves that latency isn't just a metric, it's the very currency of conversational trust.
Now, before we declassify the solutions, I want to be direct. Fixing these kinds of problems requires a serious engineering-first approach, and that's the community we're building here at Lalit Official, a place for engineers building real production AI systems, not just playing around with demos.
So here's our initial mission briefing. Our goal is to hit our first 50 subscribers before the 28th of Feb 2026. And the reward? I'm going to host a live introduction and Q&A session with that initial group. To make this happen, we need you to execute, share this with other backend and AI engineers, like the video, and most importantly, subscribe to the channel. Okay, mission understood. Now for the solution. Part 1 is about declassifying the first critical architectural shift you need to make, separating the media plane from the control plane. This is the second huge mistake. On the left, you see the relay architecture. All audio flows from the client through your Python server to the AI provider, and then all the way back again. Your server becomes this slow, expensive bottleneck. The solution is the gatekeeper architecture. The client establishes a direct, low-latency media channel with the AI provider using WebRTC. Your Python server's only job is to authenticate the user and issue a short-lived token to permit that specific connection. This quote captures the essence of this pattern perfectly. You move the heavy processing, the audio stream, away from your server. You offload it to specialized infrastructure, but you keep the control, the authentication, the permissions, the logic on your server. Your backend becomes an intelligent authority, not just a dumb packet router. Okay, so on to the second part of the solution. Once the AI is thinking, how do you let it actually take action, like checking inventory, without creating a massive security hole? Well, this is all about mediating its agency. And here's the third mistake, treating tool calls from an LLM as if they're trusted API invocations. They are not. The correct pattern is a secure loop. 1. The model suggests calling a tool. 2. Your backend validates that suggestion against a strict schema. Does the function exist? Are the parameters correct? 3. Only then does your backend execute the function in a secure environment. And 4. A safe, validated result is returned to the model. The AI never executes anything directly.
This really gets to the core principle. The LLM is a reasoning engine. It can propose a course of action. But your backend infrastructure must always maintain the keys to the house. It is the absolute authority that validates, authorizes, and contains every single action.
Finally, let's declassify the third and final piece of the solution. And this one is a big mental model shift. You are not building a web app. You are engineering a stateful circuit.
So here's the blueprint. The edge is your client, handling the UI. The media plane is the AI provider, handling the real-time audio over WebRTC. And your control plane, that's your Python backend with a state store like Redis, manages identity, session state, tokens, and that secure tool execution loop. This architecture directly addresses the biggest production risks out there: prompt injection, runaway token costs, and state desynchronization.
So this is what we mean by a stateful circuit, a persistent, continuous session. A voice conversation isn't a series of stateless, disconnected REST API calls. It's a single, stateful connection that has to remember context across multiple turns. Thinking like a telecom engineer, not just a web developer, is absolutely key.
Okay, let's consolidate all of this into your final intelligence summary. This is what you need to take away from this.
Here are the 3 critical mistakes. 1. Using that slow, sequential pipeline. 2. Relaying all audio through your backend, creating a massive bottleneck. And 3. Blindly trusting the LLM to execute tools. The correct model is to separate your media and control planes, validate every single action the AI suggests, and manage your state and cost with the discipline of real infrastructure engineering.
And if you remember only one thing, make it this. Building production voice AI is a systems engineering challenge, not a prompt engineering one. The cleverest prompt in the world will never ever save you from a broken architecture. This is what we focus on at Lalit Official. We are here for the engineers in the trenches, the ones building the production AI systems of the future.
So it's time to execute the mission. Share this explainer with other serious AI engineers. Like the video to signal its value. And subscribe to the channel. Help us hit that initial target of 50 subscribers. Let's start building a real, production-focused AI engineering community together.